Which pair of reagents below can be used to prepare an aqueous solution containing copper 2 sulfate as the only salt? We know that copper 2 sulfate is a soluble salt. Okay? So therefore there are two salt preparation methods that we can use, either titration or acid plus excess insoluble substance, which can be your metal, base or carbonate. Option 1. Copper metal is unreactive. Therefore, A is wrong. Option B. This is an acid plus a salt. Okay? So there's no reaction. You put a cross. This is a salt plus a salt. We usually mix two salts to form an insoluble salt, which is in precipitation. But for this one, we want to form a soluble salt, so we cannot use the precipitation method. The last one, copper 2 oxide, which is a base, reacts with your acid. Okay, so this is just an acid-base reaction to form your copper 2 sulfate salt plus water. So the answer is D. The solubility of some salts of metal X in cold water is given in the table below. Okay, we see some of these are insoluble, so we can immediately cancel out sodium because we know all sparse salts are soluble. Now let's look here. Magnesium. Magnesium sulfate is soluble because your insoluble sulfates are your calcium, barium and lead. Okay, so this is soluble, but here says insoluble, so this is wrong. Let's look at lead. We know that the insoluble chlorides are your lead chloride and silver chloride. Okay, but here says soluble, so we know this is insoluble. Lead chloride is insoluble, so this is wrong. Okay, barium. Barium sulfate is insoluble, so it could be this. Barium chloride is soluble, so yes, it fulfills this. And barium carbonate is insoluble, so the answer is A. For this section, you need to be able to identify what method to use to prepare this salt and what reagents to use. If it helps you, write at the side what are the three methods that you can use. So the first one, I can use titration to prepare a soluble salt, or I can use the acid plus your excess insoluble substance to prepare my soluble salt as well. And the last one is precipitation to prepare an insoluble salt. So if I know that the salt is insoluble 100%, I'm going to use precipitation. Okay, the key difference between these two, titration is soluble plus soluble to give me soluble. For this method, it's soluble plus insoluble to give me a soluble salt. So in order to do this, simply you must memorize your solubility table. Okay, first question to ask ourselves, is this salt soluble or insoluble? Based on your solubility table, we know that for chlorides, silver chlorides and lead chlorides are insoluble. So since bromide is in the same group as chloride, it will have similar properties. So therefore, silver bromide is insoluble. Insoluble, 100%, I'm going to use precipitation. For precipitation, you can simply separate out the components in the salt. So for reagent 1, I will have silver something, and to fulfill the other one, it will be something bromide. So I want to make sure both are soluble because precipitation is soluble plus soluble gives me something insoluble salt. Okay, so we know all nitrates are soluble. So I can just write simply silver nitrate. And I know all your spa salts are soluble as well. So I can write here sodium bromide. For number 2, we know your spa salts are soluble. So for your ammonium sulfate, it is soluble. So it's either titration or acid plus excess insoluble substance. Okay? But since we know it's ammonium, your starting reagents are most likely to be soluble. So if you see, if it's a sodium, salt, or potassium, or ammonium, most likely you're going to use titration. For titration, you can use acid plus alkali, or your acid plus your carbonate. Okay, so if I have a sulfate here, what acid will I use? It must contain this sulfate thing. So it is sulfuric acid. What is the second reagent I can use? I can use ammonium hydroxide, or I can choose to use the carbonate. Ammonium carbonate. Okay, let's move on to the next one, barium sulfate. If we look at our solubility table, we will know that the insoluble sulfates are your calcium, barium, and lead sulfate. So this is insoluble. So 100%, I'm going to use precipitation to form my insoluble salt. So it's only for precipitation where you mix two salts together where you can split up these two. Okay, so I'll write one here, barium something and something sulfate. So similar to this one, I just want to make it soluble so I can follow exactly. I can use barium nitrate because all nitrates are soluble, and I will use sodium sulfate. If I want to use potassium, it's also correct. Next, iron 2 nitrate. All nitrates are soluble. So it's either method 1 or method 2. Remember, for method 1, it has to be soluble plus soluble. So let's look here first. If it's a nitrate, I will need nitric acid. If I guess I want to use titration, so let's say I want to use iron 2 carbonate. Iron 2 carbonate, remember all your carbonates are insoluble except for your spar. So this will be insoluble. So it cannot be titration, because titration, it has to be soluble and soluble. Now it's soluble and insoluble. So the method that I'm using is your acid plus your excess insoluble substance. Okay, remember this one can be your metal, base, or carbonate. So in this case, I use the example of a carbonate. So over here, I will use iron 2. I must fulfill this carbonate. If you want to use the base, it will be iron 2 oxide or hydroxide. Or if you want to use the metal, you can use iron. Okay? Write the chemical equation with state symbols. Okay, that means you must tell me whether it is solid, that means insoluble, aqueous, that means it is soluble, can be dissolved in an aqueous solution. Is it in the gaseous state, or is it in the liquid state, which is your water? Okay, so reaction in A part 2. I want to form ammonium sulfate. So I can use sulfuric acid and ammonium hydroxide or ammonium carbonate. Let's use the example of the hydroxide. So, some of you are not comfortable writing the chemical formula straight away, which is okay. So we write the word equation first. Okay, but finally your answer must be chemical equation. Alright, so I use sulfuric acid. I'll write it down. Sulfuric acid plus ammonium hydroxide gives me, if I don't know, I will look acid and alkali. Okay? Or acid and base reaction gives me salt and water. So my salt is ammonium sulfate plus water. Okay, done. So you want to translate it into a chemical equation. Sulfuric acid is H2SO4 because the sulfate is SO4 2 minus, hydrogen ion is H plus. So I do my X-Men, I'll get H2SO4. Okay, so this is aqueous plus ammonium hydroxide aqueous gives me ammonium sulfate. Ammonium ion is NH4 plus. Sulfate SO4 2 minus. So I need to do my X-Men. I will get NH4. I bring the 2 down. Then my sulfate aqueous plus water liquid. Okay, I need to make sure I balance my chemical equation. I have 2 of these ammonium ions, so I need to put a 2 here. Okay, then I realize I have 2 oxygen and 1, 2, 3, 4 hydrogen. So I also need to put a 2 in front here. So this is the completed chemical equation. Okay, write the chemical equation with state symbols for the reaction in A part 4. I want to make iron 2 nitrate. So to make it easier for us, let's write out the word equation first. Nitric acid plus iron 2 carbonate gives me what? This is my acid plus my metal carbonate. So I should get a salt, water, and because there's carbonate, I should get carbon dioxide as well. Okay, so the salt that I'm forming is iron 2 nitrate plus water plus carbon dioxide. Okay, so I just translate this into a chemical equation. Nitric acid is HNO3 because your nitrate ion is NO3 minus. Then my hydrogen ion is plus, so I cross it, I'll get HNO3. Okay, then I'll plus my iron to carbonate. This will be Fe2 plus, this will be CO3 2 minus. So I cross, I reduce it to the simplest form. I can just cancel out these two. Okay? So form FeCO3, which is insoluble. So I put solid S. Okay, gives me iron, nitrate, plus water, liquid, plus carbon dioxide, gas. Similarly, I must balance out the equation. There's 2 nitrate ions here, so I put a 2 here. My equation is balanced. Okay, done. Describe the procedure to prepare a dry sample of calcium sulfate. Dry sample of calcium sulfate. Okay? So, first question to ask ourselves as usual, is this salt soluble or insoluble? We know our insoluble sulfates are your calcium, barium, and lead. So calcium sulfate is an insoluble salt. So 100% I know I'm going to use precipitation. So for precipitation, I can just split these two components. So I need to use calcium something and something sulfate. Okay, this is only for precipitation. So I want to make it soluble, I can use calcium nitrate and sodium sulfate. Okay, so 4 marks, I should have at least 4 points. My first point would be to mix the state. I don't just say mix the solutions together. Mix the calcium, nitrate, and sodium sulfate together. Okay, and what happened? To form your calcium sulfate precipitate. Okay, your precipitate is the insoluble substance which you are forming here. Okay, then after that, in your solution, right, there's your insoluble calcium sulfate which is precipitated out. So you want this. How can I get this? I can use filtration. Okay? So if I use filtration, I will want the residue here. And then my filtrate is here. Okay, so I'll say filter the mixture to obtain the residue, which is your calcium sulfate. Once I filter, I obtain this residue. Okay, this is your calcium sulfate. I will want to wash. With distilled water. And because I want a dry sample, I will dry between sheets of filter paper. Okay? State the color you observe when I add universal indicator to a solution containing calcium sulfate. Okay, calcium sulfate is actually insoluble, so it will just be a solution with your calcium sulfate here. Okay? Do I change the amount of H plus or OH minus ions? No, I do not affect them at all. Okay? So even if my salt was soluble, for example, sodium chloride, I dissolve in the solution and I get my salt water. I am just adding sodium and chloride ions into the solution. I'm not changing the amount of hydrogen ions or hydroxide ions. So my pH is not affected. So the pH should still be neutral, 7. So the color is green. These are the respective formulas of these common ions. The ones that I've circled are the ones where my students usually have errors in them. Okay? So please take note of it. If you are unsure of all these, you can just refer to your periodic table to guide you.